So what we're going to do today is calculate the volume of the Berkeley Pit. Everybody's number is going to be just a little bit different, but should be in the same ballpark. And I'll explain why when we get into it. I'll give you a second to download that. All right, so first thing I'd like you to do is bring in the file C4250, ARC C4250. Into your map. And you will get the error that you should be, at this point, familiar with, unknown spatial reference. This is a shapefile, not a raster, but it does not have a coordinate system. So you can say, okay, for now, we're going to turn this into a raster so that we can georeference it, because you can't georeference a shapefile. But the reason this isn't georeferenced is that this is a file from the Anaconda Mining Company, and it was in a proprietary coordinate system. So this is a coordinate system that was developed by the Anaconda Mining Company for the Berkeley Pit. And what that means is they arbitrarily chose a 0 point down here, and the rest of their coordinate system, this is not the entire system, but this is the rest of their coordinate system was assigned based on internal information that they did not release to the public. So in this case, they know exactly where this is, and they have a coordinate system that this applies to, but you can't go into GIS's coordinate systems and say, apply, this is the coordinate system. So in this case, we're forced to georeference it. And we have to do that based on the information that's in the map. So what I'm going to do, just to save us a little time, I gave you another map, the Google Earth image in that Google Earth pit. If you want to bring that into your map and zoom to that layer, oh, we're going to have to set our coordinate system. Set your layers, your data frame coordinate system to UTM 12 north, please, to make that look normal. This has been georeferenced, and UTM is under projected coordinate systems, UTM NAD 1983, UTM zone 12 north. That should update that image. Why isn't mine updating? There we go. Okay. So in this case, we don't have information from the, I guess it's the 70s, when this was actually mapped, because this is before they turned the pump off on the Berkeley Pit. This is what the Berkeley Pit looked like before they turned the pump off. I think it was 1982. So these are the layers that were cut into the earth, and it's their contours around the layers that they cut down into the Berkeley Pit. So what we want to do is we want to take this, we've got an approximate shape where the Berkeley Pit is. We want to take that and georeference it to our Google Earth image that has already been georeferenced. And I'm using Google Earth here because the only reason I'm doing this instead of having you stream the nape imagery is because the nape imagery is just so slow on these computers. It was completely unnecessary to use a Google Earth image and georeference it. So just ignore that step. Assume you're looking at this from another perspective. But what we want to do, I don't know why it's shrinking this at this view, but we want to go ahead and georeference that ARC 4250 to Google Earth. And in order to do that, we have to turn this into a raster file. So the first thing we need to do is convert this to a raster. That's Toolbox, Conversion Tools, to Raster, Polyline to Raster. Conversion Tools, to Raster, Polyline to Raster. At the end of this exercise, I'm going to have you guys email me the number we come up with for the volume. So please do stop me if you get hung up on something, just to make sure you get to the end result here. So polyline to raster, use that ARC 4250 as your input file. I'm going to put this on my desktop in that Berkeley Pit folder. You want to set your value field to Z, because in this case, what we're interested in is those contours are depths. So we want that third coordinate on here. We want the Z value field to be what the raster recognizes. You can leave your cell assignment type to maximum length. We don't need to set a priority field, but our cell size, let's set that to 50. We're going to do some more raster math. We're going to compare rasters again today like we did last time. So we want to make sure all of our rasters are in the same cell size in order to make that math work a little better. I'm going to give you one warning here. Because we're going to georeference this raster, the output data set, if you don't assign a file type, it's going to automatically be Esri grid. So it's going to be .grd. You cannot update, or you can't update a grid file. So when we go to georeference this, if it's a grid, you have to hit rectify. You cannot update this as a grid. So if you want to use the update instead of the rectify tool, when we georeference, put a tag on this. Make it a TIFF, a bitmap, a JPEG, something like that. I'm going to make mine a TIFF, so that I can use update georeferencing. But if you don't, you have to rectify. And then say OK. Gabe, in just a second, I will come over and help you, but everybody's got to start georeferencing here in a second, and I'll get you up to speed. As soon as that comes in, you can take a look at that and see you still get the general shape of that, and it's unreferenced if you want to turn this off. You still get the general shape of what the Berkeley Pit looks like. If you want to use those shapefile lines, that might help. But what I want you to do is go ahead and georeference that to your Berkeley Pit image. I don't know why mine is goofy at such a small scale, but pick locations that follow the approximate perimeter of the Berkeley Pit and georeference that raster. If you need help with georeferencing, raise your hand.
Were you able to figure anything out for that?
I didn't get a chance.
Oh, sorry.
I'm eating all weekend. I just didn't get a chance to do anything.
Oh, correct.
No, we're calculating the volume of the Berkeley Pit. Usually comes out pretty high. Yeah. So bringing Google Earth Pit and ARC 42. that one is a shapefile, but we can't georeference a shapefile. We'll get to that in a second. Bring it forward a bit. So that's what the pit looks like right now. I could have given you an image through you, but the stream server are so slow. I just could have Google reference this. So this is a JPEG. The goal is to turn it into a raster so that we can georeference it. Put your coordinate system in UTM zone 12 first of all, data frames so that we know what coordinate system we're assigning.
This is where I was. This is when I was just like, oh, okay.
So now we know what coordinate system we're going to be georeferencing.
Yes.
So the next thing is go into a box.
So I assume that that's supposed to be
More conversion.
this capture this or something.
You
So
want
do you think I should do
It's
this?
to raster. From poly to raster. Yep, that's the one. So set the input features.
So do this with me or should
And we want value field to be C because these are depths.
And then, so after I do this, I'm just gonna define project that.
Nope. Let me give me 1 second. I gotta do it up on the front because I don't think I gave it to you. So do the value field to Z. And just put it wherever you want it. Okay. So if you don't put a extension on that, it's going to be a grid file. And grid file, because we're going to georeference this, you have to rectify a grid file. If you put an extension on it, you can update georeference. But we have to have the extension, or you have to rectify if you don't put the extension on. The maximum is good, priority field is good. We want to set cell size to 50. And we want priority field to be 9. So we're going with 50 because the original arcs are at 50-foot interval. We're going to have rasters that we do math on, and we want them all in the same size. So we'll stay with 50 for this one. So okay, you're good to go. Now the next step is when that comes in, georeference it to your Google Earth pit.
I have a question for you. So I can try to put me like this one.
Yeah.
Okay, so hit that move a little bit, it should pop back in. Every time you add a point, it moves that, so you can treat all of these just like a regular.
All right.
I'm sorry. Well, there's been some little, that's just no response. First step, number one, we're trying to get into the right. Post, right?
Okay, so Google is over here. So leave that alone.
I just stick on.
Okay, so
Is that right?
no, that's gonna mess that up, so.
Okay, so since now.
Yeah, let's get it in the video. Just bring it. Let me see what the point is.
Okay. Should I re-download?
If it's not in UTM zone 12 north already, I can't remember what it was. We'll have to re-download it.
I think it was. And that's why I felt so weird.
Let me just verify that in case, because it's gonna mess up the, yep, you're good. So just leave it.
Okay.
Just leave it. You didn't change it. Oh, and I gotta show this to Gabe real quick. Gabe, this is why we're doing this. This is a proprietary coordinate system from the Anaconda Mining Company. So we don't know where the 0 point is on this. We can't define projection because that coordinate system is not listed in GIS. And the Anaconda Mining Company doesn't exist to give it to you. MR won't give it out, I've asked. So we have to assign the projection. This is what the Anaconda Mining Company's coordinates looked like, but we don't know what their 0 coordinate was, so we can't make the projection switch. So we're georeferencing instead.
So yeah, it was like step one. I couldn't.
You see where it is? Put it on top of the Google Earth file so I can see where it's on top of the Google Earth file.
Oh, I see.
slide it up so I can see it.
Is this what we're? Yeah.
It should show up. It looks okay based on your points. I mean, and as everybody georeferences and draws parameters, it's just sort of different for everybody, but I would call that good.
Or what it is.
This looks like this. Okay, no, we're not doing that. So we are. Oh, you're in the way.
Well, no,
Okay, now let's set that to the.
the layer properties,
Yes.
that's what
Okay,
I,
It's gonna be under.
okay, there you go. You're good. So all we're doing, you need to know what the data frame is in, and I chose the one that the keyboard images in, so that when we do the georeferencing, we know what coordinate system we're georeferencing.
that's stuff.
Okay.
So right now, capture the polylines.
Yep. So then we want to set value to Z.
Insulation. These lines are pretty watery.
Yeah, this is actually the bottom. This is not water.
Where would you find it?
Or to georeference it.
Yeah.
See the approximate shape of, you can see where it kind of goes off.
This is safe, but
That's the perimeter of the pit where you just run your finger.
this one.
Yeah, that's
Okay.
the approximate perimeter of the pit. So the perimeter is not where the water is, it's where the land surface is.
So I was thinking like, this is up and then you flip down.
Yep, that goes down into the pit. Yep,
So
basically, that's approximately how it goes. And it's okay, this is a little bit off, this doesn't have to be perfect. It's just about kind of going through the steps.
Mhm.
Okay, so maximum length, and then cell size 50. We want the cell size to be 50 on everything, so we're going to do raster math, and it's easier if they're all the same cell size. So what we've done is we have told it what coordinate system it's in. Now the one that is georeferenced is in the same coordinate system as the layer frame. We convert that with to a raster so that we can georeference. And so now we're georeference that as we want to georeference that as a raster. So close that out. And we're going to look at georeferencing. Just make sure that it's not going to blur that tip. You want to leave that polyline in. There you go. Now we just need to georeference that.
Oh, wait, I'm looking for those, this one.
Yeah. If you want your little engine, that'll help you.
Yeah, mine's in
Okay. So this is the perimeter. This is the approximate perimeter of the pit here. You can kind of see a bump there, you have a bump there. That's this little bump here. And,
Okay.
you know, just give it an approximate location on the pit.
Okay.
Does that make sense?
Yeah.
Okay. Anybody else? Good? Doing that?
Oh, boy.
Yes. Yeah. There's a lot of bugs going around this time of year. Season. You doing okay?
Thank you, Stone.
Got it to rectify?
Well, so,
Yeah, whichever.
got it here.
What one do you click first?
It's not showing the picture.
This.
Okay, can I see? What else do you put in the-
It's just
I'm,
Just wanted to first time to.
You did when you had update to your records. You created, did you rectify? Okay, so go grab, because rectify creates a new file, go grab that one and bring that one in.
Yeah, that's what this one is.
I'm not sure.
I don't know. Why don't we do this?
Um,
You see that?
basically, let me, yeah, it's just gonna do that, so you need to hide it, bro. So you get like 3 points and it's a lot better.
Well, what? Why is it like that? But this?
Yeah.
Yeah, you
Yeah, this
showed
happens.
me that you had your points with them. What did you
Next
just
second
want
one doesn't show up, but it's
Oh,
you would grab just something.
I made that point, but it doesn't show up.
it's annoying.
Huh?
It's annoying.
It's gonna restart.
Originally. You have to do 4 of them at least.
Most of it should show up. With one, verify it.
Yeah. There it is. Okay. Now, I don't know why we're doing that. You must have your automatic.
I turn on my auto adjust.
And this.
That's what it is. The
I'm
auto
the
adjust
primer,
or
or this whole thing.
was automatic.
You don't get why they just.
That's not what's happening. Okay, so I.
So this
Most of
is the
the
one through.
This one, this one.
you were stepping in. Okay, so yeah, you're good. You should be able to rectify it and rewrite it and if you want to do that
And
again.
when I go far out.
I would rewrite that one. So it's showing up and I don't know what happened.
Okay.
But
Shoot, they let
it should be good now. That should, when you bring that one in, it should show up on there. And it's close enough that you can find it.
No.
Do I need to change the cell size to 50? Or just keep it?
Yes. Your cell size.
Even here. This is- okay, that's what-
Oh, nice. I think this is like a little bit.
Okay, everybody's got their raster showing up on top of their Berkeley Pit? Well, you're okay, Ashley. Take a minute because I got to do mine too. I got to create mine as well. Damn it. My map is doing something weird every time I try and zoom in on it. Zoom out on it.
Same thing.
I don't know why. That's really strange.
So my points will show up.
I don't know how good that was. Good enough. Did you put a tag on the end of it?
Or did you say like that, or that EMP, or did you just leave it blank?
I'm like right here. Oops.
Looks like you're pretty good. Because you didn't put a dot tip or anything like that. No, you're okay. I just said that because of that, you have to rectify, you cannot update your referencing because grid files will not update. So we're just gonna rectify that one, save that wherever you want. It's gonna come in as a tip, but put that wherever you want.
Did you see that? What happened? Oh.
Oh, I'm sorry. It's looking at the workspace. Yeah, I'm sorry.
Okay.
There you go. Now. if you want,
Oh.
I'll write it.
Yeah, they don't know.
I'm sorry.
I know what you're saying.
Now, you can go get that file and bring it into your Mac.
Mine showed up. Let's go to here, see if there's a certain preference that, this,
No, it's not.
that's weird.
There it is. Okay, now we can move all around. That one is not really you.
Does it show up here? Or
Okay.
All right. I did the first one.
Okay.
Wow.
You're okay?
No.
Oh, I'm sorry. Wait, ignoring you. I didn't realize you was a-
Wait, 4 points.
Okay, so turn it on. I can see it. You're having the same problem. Okay. I don't know what to do this with this custom mouse. Just do it really fast. So I'm gonna do that with mine too. So
Yeah, it was falling.
it should get. Something's going on with that. Let me close it out and start it. Sorry. Get you up to speed real quick.
Yeah. So,
Good. Okay, so let's try this again. So something is just. I don't know what it was, but I don't know if there's another fix it. So you're just right.
maybe it was working. Like you could start it over.
Just a thing that's deep. Okay, so that's approximate. It's good enough for the purposes of this. So it's a tip. Okay, so you can update. Now, save to your reference.
That was an update.
Yep, I did update because you tagged it with a tip. It's only if it doesn't have that extension and it's a grid file that we have to use rectify, and then you have to go grab that file and bring it in. Because rectify creates a new one. Okay. All right, everybody's got a georeference. So our next step. So we want to create two different surfaces from this. Our goal here is to figure out all of the points. Our end goal is to Krieg a surface, and Krieging means effectively smoothing that surface out. These are contours, but what we want is a continuous surface. So our goal here is to make two different things. One, draw the perimeter of the pit as a shapefile so that we can grab everything inside that and Krieg a surface that's at the bottom of the Berkeley Pit. Then we want to grab everything outside of that perimeter
and create that. And that, well, that won't be the top because we don't know what the original top looks like. It'll be a flat surface across what's missing. Does that make sense? So the next step, it'll help if, don't get rid of this, but uncheck it so you can see it. Draw a perimeter around the Berkeley Pit along the soil line, not along the water line. That is the top of the Berkeley Pit. So we want to create a brand new shapefile that we can use to select everything inside and everything outside of that point. You guys remember how to draw a brand new blank shapefile? And it's got to be a polygon, not a polyline, because we need to select inside and outside of it. Keep your coordinate system in that UTM 12 north. This is an example of when it's really important to stay in the same coordinate system with all of your files, because GIS is going to get confused if you're doing all these manipulations with different coordinate systems. Everybody got a new blank polygon shapefile? So the next step is turn editor on and draw that shapefile. If your create features doesn't show up, go up to editor, editing windows, and click on create features, and that'll make that create features window show up. And this doesn't have to be exact again. This is just like georeferencing, just get the approximate shape of the outer pit.
So we need to create a new. Okay, all right, so we want, so we want to go to create features. So select perimeter.
Yeah.
And then, yeah, just click and then and draw. Polygon works best. Unless you do preset it. Yeah, and then just one click, put the point down. Don't go through the water, go through the perimeter of the soil. Hover over it with your mouse. Right click. Delete vertex.
If you guys accidentally lay down a bad point, you want to get rid of it, you can hover over it with your pointer. I don't know if you remember this. If you put down a point and it's not where you want, hover over it with your pointer, right click and say delete vertex. If you've completed your sketch and you want to draw something different, you want to edit it, you have a tool in here somewhere, edit vertices. This is your edit vertices tool. If you highlight that, it'll let you hover over and move your vertices around once you have finished your sketch. This tool right here, edit vertices, if you want to change it. But when you're happy with your perimeter, stop editing and save that perimeter. You need a handout?
Oh, you don't have to match me because I'm really flying through when I just throw my points down. So your approximate locations are going to be better than mine. I'm zipping through it so that I can go help people and not hold them up doing it myself.
So you edited your vertices when you saw images versus state or something?
So, yeah.
Just so
Finish the, are you good with that?
sure.
Perfect, all right. So then hit editor, stop editing and save your edit. We want to keep that file. And it's up to you if you'd like to make that hollow so you can see this, do so, but you don't necessarily have to. I'll blow mine up so you can see it. You can see my perimeter there. I can't get the whole pit in view or it shrinks it down for some reason, but this is my approximate perimeter. Now, I'm going to turn my contour raster back on. I've developed the pit of the perimeter, or the perimeter of the pit, and my raster file is Z elevations. Remember, that's each of those little pixels that we can see is an elevation of the earth. So what I want to do now is create two separate rasters from this. One is the inside and one is the outside of the pit, so that I have two different surfaces that I can subtract one from the other and create the volume inside. So what I want to do is a spatial selection, select by location. I want to select from, oh crap, no, I'm sorry, I can't do a spatial selection on a raster. Oh, I'm skipping a step, sorry. What I need to do now, the only reason we created this raster was so we could georeference. Now, we need to turn this into points that we can select inside and outside of the perimeter. Sorry, I skipped a step here. We want to convert this raster back. We don't want it to be a polyline. This time we want it to be points. So we're going to go the opposite direction. This raster we just georeferenced, we want to put that back into Z points. So that's again a conversion tool. Damn it. And this time, it's from raster to point. And because it has the coordinate system applied to it now, it's going to keep that coordinate system in those Z locations, those Z elevations are going to be located. So our input raster is, of course, the one that we georeferenced. Our value is the Z, if you want to open that up and look at it. Oh, we can't see the attribute table on that. The value is what we assigned as the Z. So just make sure this is going where you want it. And it's going to come out as a point shapefile. I'm going to uncheck that so we can actually see it. So you should get a pretty heavy grid of points. This is what we're going to do the spatial selection on. And Krieg. Yep.
So my raster pointed it. It's giving me blue dots, but the blue dots don't exist.
Oh, this is into layer on.
They're on top. So it should be.
Yeah, but they're on top of the unreferenced file. So,
Cool. So reference it.
yeah, that's going back all the way to referencing it, or to georeferencing it. Didn't georeference correctly. Cool. Sorry. Set this up to, or whichever one you had, set it up to georeference. So yours did georeference here. Okay. These two need to read georeference and then go through everything and get caught back up. Can you help them?
I'm assuming it will.
Your concern outer space. Something's happening with these. Okay, so can I see your, actually, I'm sorry, Jeff. Can I see your georeferenced arc, your contour raster reduction? So which number it's supposed to be? Right click on it and use the properties. Just make sure. Oh, did you rectify it or did you update your reference? Let's see the source.
So we gotta start.
Hey, Tyler, they might not have updated georeferencing. Check and make sure if it's TIFF, if they updated georeferencing. If it's not, if it's a grid file, they probably didn't bring the new rectified raster in. So, looks like you had that georeferencing. You just did it now? Okay, now go through the steps again to turn that into a page. You just forgot to update it, so you had done the georeferencing, but it didn't save it yet.
Okay.
That's something that happened in YouTube.
Properties.
Hit update georeferencing.
Oh, there you go.
This is the old
There
one
you go. Okay,
to go from your catalog.
now you're good. Okay. That's probably what happened to YouTube too, because it looks like it's in the right place.
If you saved your georeference, so now you
Gabe, show me the one you georeferenced, the file you georeferenced. Zoom to layer on that one.
Which one?
The file you georeferenced. The
should be
the raster that you georeferenced.
Oh, well, I just plugged in the, so it's right here. And I georeference it. All right.
Oh, you assigned UTM zone 12 north to ARC 4250?
Yes.
Okay, that is not correct because it was undefined. It didn't have a location. It was not in UTM zone 12 north. So we need to clear the failure points. Okay. Where are you putting the files that you created?
There.
Where are they saving? So you did not update this one. Okay. I think what happened was you did not hit. What's this? So I'm gonna georeference you really fast. Would you check and see if he's either updated or rectified? Okay, so that needs to be rectified, which means, did you ever hit update your referencing or rectify? No. Okay. That's what happened. So it didn't save the spatial information. So let's just do that really fast. I can do this really quick. You want to do it? Okay. Okay, so you have to hit rectify because you kept the grid, yeah. And then when you do that, go get the file. You need to know where it's saved, and then go get it because it's not gonna be the one that you're working from. It's gonna be rectify and creates a new file. So if you uncheck it over here, you can see it. What is this? Raster? Yeah, that's strange. That's the georeference.
This is just the georeference. I see.
So you call it raster one. So this is your original raster and previous. Yeah, there's a top. Okay. Update what you wrote. Now Now it's saved, you basically just saved the coordinate system to that file. So now turn that into a raster clip. Just give it a location. Just call it points. Okay. All right, so now we want to convert that to points. So now do the raster points. Okay, you're all set. Now your points should come in. Are you good, Ren?
Yep.
Jasmine?
Yeah.
Okay, perfect. Great. All right, back on track. Now do that spatial selection.
Select by location. We want the elevations or the points that are inside the perimeter. I'm going to use R within the source layer feature because my source layer is perimeter. Do not apply a search distance. This is what constitutes what has been cut out of the Berkeley Pit. Okay? That is the bottom of the Berkeley Pit. And that's what we're going to use to create the contoured surface of the bottom. So export that and call that bottom.
What if mine aren't highlighted?
Why is that not valid? Oh, if it's telling you it's invalid, sorry, 1 second.
That's just
If it tells you that your file name is invalid, open a folder and make sure it's set to save as a type of a shape file instead of a file in personal geodatabase. Okay? I saw you shrug. Are you okay?
I was just looking at it.
Oh, okay.
Yeah.
All right. To get the top, we need to do the exact opposite. Grab everything else. So you can do that by switching your selection. Everything that was not previously grabbed. That gives us the top of the Berkeley Pit. Same thing, export that and call it top. I'm going to uncheck elevations and make these, well, I guess they are two different colors. You can see that I'm now looking at the same points, but I've got them separated into inside and outside of the perimeter.
Once I hit stop editing on the on my edit pet line, it's started giving me that I have 0 within.
Oh, okay. So you're, oh, it is.
That's what I chose to call it.
You did. Sure. You see that?
Well, the whole day I was working on started.
Select it so I can see it blue. It's showing up. I don't know what's happening with that.
I actually
It was because when I hadn't, because I had submitted that where I was exports.
Yeah.
So then I went and actually found that I was still in it. And then it started doing this.
Okay, so
Yeah, it's like.
That one picture is a thing that we just.
yeah, so selecting from the points inside. It should work. So I think it's got to do something. I tell you this, but close it out and we add the edge of pit and the contour points. That's all you need, right? Well, maybe those exist. You're not going to lose them. If you select this, it's just like those GIS. Bring them back. So that data all exists. You don't have to go through all of that again.
That's so funny. I'm just squeezing it.
Do very often. I used to live on flats, so.
Yeah. Yeah, my friend lives on the flats. I like being a town. I like being a town.
Just see it.
I haven't been read that in a long time.
So let's go back. Where is the file? Bring that up again.
Woke up and I'm like, oh no.
So yes, convert that one again to points. And get rid of the contour. I don't know what happened with something.
And I like woke up at bed and used to
So that was the
That
other
was not good. It's so beautiful. The lips are like a weird.
But it's what I want to have these things in school. Said it's cool.
So that one needs to default to your database. Make sure you grab it to default. Like that. I mean, that is so stupid. It's so infuriating. But those are coming. These are coming through the space. Dumb as that is. Yeah, might have, and I just.
Yeah.
Because like it created the points, showed me the points. But it was an empty base. Ended it even. I'm sorry, that was very error.
So I just. As soon as I was take this off, it just disappeared.
Fire. Okay, outside security. Okay, it didn't get anywhere looking outside. So what the graphical ones, go back to elevations.
I just said okay. And I just like did that. Just
So what I would suggest, the only thing I'm really doing is your raster and vertex. Inside. All right, so let's keep the inside and get rid of points June. Okay, so now in elevation, you can uncheck the one most like elevation. Okay. So we want to select from points Q instead of points G. And then set that to the inside. Or within. Oh, there it is. Okay, so now open the attribute table, switch selection, and now say over here, don't you actually get that delete. That's what it feels. Right now, I think the export data expert is called. We'll just call that outside. Now you should have outside. You have inside, and now you should have outside. And that's all you need. Okay, so just give it a slight. Yes. So you close all that and get rid of everything except inside and outside. Just to simplify it. Okay, perfect. All right. Next step. We're going back into Spatial Analyst. So if you're on a different computer or if you get an error message, Spatial Analyst has to be turned on. So that's customize, extensions, make sure Spatial Analyst is checked. Otherwise, you're going to get an error message on trying to run that tool. What we want is Toolbox, Spatial Analyst Tools, Surface. Oh, I'm sorry. This one's interpolation. Interpolation. So we have 4 different tools here that effectively do the same thing. IDW is inverse distance weighted. Kriging, I'm not going to go into what Kriging is, but these two are basically mathematically the same. Natural neighbor is a little bit different, and spline is generally a lot more smooth. These are all mathematical interpretations that take the nearest points around a single point and create a flat surface out of them. They all just smooth that surface into a continuous surface. We're just going to use Kriging because it's a nice simple one. What Kriging does is it takes a center point and goes to the 4 nearest points and creates an average value, and it'll smooth that across the entire surface. So Kriging, we want to do just top first maybe. Our Z field is grid code. Give this a location. Don't put a space in it. Give it an underscore. It's going to fuss at you if you give it a space. I'm not putting an extension on this, so it's going to come out as a grid. My output cell size, I'm going to make this 50. And again, we want this to be the same for all of them. When you're done, we don't need to add any more information into this. We're just telling it what to Krieg, the output cell size. Did I?
Yeah.
Oh, good, thank you. Thank you, I didn't even notice that. All right, so it's also telling us that the number of points it's going to use to do this Krieg, the 12 nearest points. This might take a minute because it's doing a huge mathematical operation, but you can say, okay. Oh, come on. Failed to execute. All right. Let me try a couple things, see what it's hanging up on. It might not like that big of a cell size. Yeah, it didn't like that big of a cell size. Let's set the cell size to 10. Sorry, I led you astray. I didn't know it was going to crash on 50, but set your cell size to 10. We just need to remember that that's our cell size. Still didn't work?
No, mine worked at 50.
Oh, good. Okay, that's fine. Keep it at 50. It's entirely dependent. What's happening is the way I drew this, I have a blank space up here, and it's looking for a bunch of points, 12 points around an area that I didn't include. That's why decreasing the cell size worked for me. Leave it at 7.19. That actually just shortened it to 7.2. Let's see. Sometimes it can be.
No, apparently because I tried to do the same.
I think what's happening is and it's hanging on that. So let's try one more time and try it at 5. Give it a different name. Don't try and overwrite a previous file. Actually, since what did you overwrite before?
Yeah.
Okay, then let's hit it. Okay, so it's just going to change the spaces to clear. I'm just going to email you this one so you can do mine because I don't know how to get around this at that point. Without having to redraw printer. I've never had that happen before. You guys go ahead and do the same thing with the bottom, and whatever number you used for the bottom, use that number again, whether it's 50 or 10 or whatever. You should not have a problem with the bottom. People who are having trouble with the top, it's because there aren't 12 points outside that it can pick up. Just leave it. Yeah, your bottom will work because you have all these points. So let's
Nice. So fast. This reminds me about
one more time.
I think that's how I calculated.
Well, I'm not an expert on the layout of the Berkeley Pit, and I don't think it looks like this.
I don't think so.
Let me try this for
He's
you.
looking up the data, but I'm okay with saying.
Because what's happening is that this is more complex.
Yeah, like a pit.
Because the outside, scroll down.
Do you have a problem on that?
Let's set this to
The
5.
top looks like
And you can set that to 10.
And it's
also a little.
Okay, so let's try that. This is 6.
No, that's 6 more or less.
Okay, so it just didn't have enough points. Okay, so we're on that bottom.
No, you're good.
You have all the points in the world on the bottom. So that one doesn't have any trouble, but you guys just do it literally the way we drew it for yours. Mine did the same thing, so.
Oh, I deleted the wrong one also. Cool.
Everybody got a top and a bottom? I'm going to uncheck these so you can look at them. Well, you can see here that the top is not a smooth surface because of that creed. It's effectively kind of slanted across the pit, but as this area is a lot more complex, you're going to get a lot more variability. It is basically doing an iterative math
all around each point over and over and over and over again. As the point nearby changes, it recalculates that. So you won't get a smooth surface on that. But I need to run my bottom real quick. So what worked, the two that couldn't get it to run had a whole bunch of areas where the perimeter exceeded the amount of points. We decreased the number of points here to get that to work. If that ever happens to you, give that a shot. But bottom will work for everybody because nobody put their perimeter outside of the bottom. So this is a continuous raster of the top and the bottom of the Berkeley Pit. Now we need to do what's called a cut fill tool. That is under Spatial Analyst Tools, under Surface. And all this does, we've got a surface raster and we've got a bottom raster. All this does is calculate the volume in between those two, okay? That cut fill, the before surface is the top. I didn't name mine top. The after surface is the bottom. And we do need to change the Z factor here because this is in feet. UTM zone 12 north, the XY locations are in meters. So as we do this calculation, we're going from, we're looking at 3 dimensions, but 2 of our dimensions are in meters and 1 is in feet. So in this case, it says here, we're going from meters to feet. We need to use this conversion 0.3048. So type that in as your Z factor. If everything is in the same units, you can leave it alone. So this is my volume. And okay, I'm gonna remove everything else. This should come out in 2 colors. The blue area is the lost area. You should be able to reopen it and just bring the top and bottom back in.
No, it was the problem.
Oh, it didn't actually, it didn't crash, it just didn't run.
Well,
Oh, okay.
Oh, remind me to still have your dots.
So we have a few areas of positive, and that's the result of the kriging. That's in red. And we have a few areas of negative outside. That's fine. But what we want to do now, we're only interested in the area inside the perimeter. So we need to trim this polygon down. We want to use the clip tool. The raster clip, remember, is in data management tools. Raster processing. So we want to clip that volume to our perimeter and make sure you check that box. Use the input features for clipping because otherwise you're going to get a square. And okay. Now, actually, I should have shown you this. I'm going to open the attribute table on that volume. This is before I clipped it. This is the attribute table showing me what the volume looks like. What I want to do is look at this as a whole number. So I'm going to take this volume, and actually, because we're out of time, I'm just going to do this and end it here. On your original volume, right-click, open attribute table, You should have this column volume here. Right-click on the heading for volume and go to statistics. Statistics is going to summarize that for you. It can tell you your minimum and maximum volume, but it's also going to tell you the sum. That sum is the number I want you to email me, because that is the volume of the difference between the top and the bottom of the Berkeley Pit. Okay, so let me see that.
So let's reverse that one inside the vehicle.
So what is our volume?
Yeah,
Like what? What is it? What's our answer?
355.
24? Oh shit. I'm like 24? Alright. Mine? Is it the sum?
Yeah.
Okay. So we're just emailing her that number?
So we're.
What? Yeah. Oh, nice.
Oh, there you go.
Yeah. That is pretty much selected. Yeah.
So,
Didn't say that.
I never said.
You just put this on
Never
there.
do it.
Are we ready to sound guys?
I don't.
Oh, my knees. Oh. No one really had a choice but to
I'll be there in just 1 second, Leonie.
Oh,
It's nice.
oh yeah, they're gonna their place so. Don't you put over and we just.
Literally. Well, actually, it's not true. 1 plus and then there's being
I do like.
Like a light.
I am not forgetting myself. You guys have no idea.
Take down that song. I'll write that down.
Oh, yeah.
I will remember what's happening. Yeah.
So.
I just spent one.
Yeah. We're doing everything right. I just don't know why it's
Did Marty ever get that?
I got a question now.
There? You're in the water.
What did you find?
I don't know. It's all on the internet.
Like that's what I'm beneath the fun. So, that's the area.
You see your phones up in there?
Yeah.
Oh, turn them on.
Like the way they
Check them. Check them.
Oh.
That's all that's happening. You're just not letting them.
Oh my god, dude, that is awesome.
Yeah,
How do you
I
get
was
up there?
actually selecting them. You just couldn't see
Oh,
if they
why?
weren't turned on. So
Well, I was like reading that and saying zero.
You're like have the best
It's like
word of
a-
your life. I kind of hate you.
it's obviously selecting.
It's way You're so sorry.
Oh, yeah.
Oh no,
Like that, that's awesome.
Yeah.
Probably.
Love at the time of your life.
Slow on actually waiting with
Oh yeah, you know it.
it's doing it
Yeah, look.
right.
Yeah, that is awesome. Worked out for the best. Better for you. Bye. Thank you.
Nice feedback, Mary.
Sorry.
You're good.
You want to get rid of this? Okay, now you got those?
Got it. That's what I was trying to figure out.
Oh, I'm sorry. That was holding you up. Okay, so
Yeah, you
you got
just,
the
you know,
outside.
one of those things.
Got it?
Yeah, there's a million steps, I understand.
It depends on the size of the body.
Call it.
Yeah.
Cool.
All right, so this sum number for the camera is the number you want to email me.